Welcome to yet our new lesson of organic chemistry. We are starting a new homologous series, and this is carboxylic acids. If you've been following us, we've been moving from all the homologous series in steps. We started way back with alkanes. We've gone to alkenes, we've gone to alkynes, benzene and its compounds, alkyl halides. We've gone to alcohols, carbonyl compounds, and now here we are. We are in carboxylic acids. What a journey. Now, someone would be interested in knowing what are carboxylic acids. In this lesson, we shall be answering that question because it is simply the introduction of carboxylic acid. We shall be knowing how do we name carboxylic acids. If they are isomers, how are the isomers written and what are they of the carboxylic acids? So, in this lesson of carboxylic acids, we shall just need to know what are carboxylic acids. So that's the first thing. What are carboxylic acids? So, carboxylic acids refer to organic compounds. Organic compounds with the carbonyl, with the carboxyl, not carbonyl, with the carboxyl functional group. With the carboxyl functional group. Now, its name is called the carboxyl, not carboxylic. It is the carboxyl, not carboxylic functional group. Now, the carboxyl functional group must be present for a compound to qualify to be a carboxylic acid. And they are generally, represented by the general formula. They are represented by the general formula CN H2N O2. This is the general formula of the carboxylic acids. CN H2N O2. However, we also represent them as just R COOH. This is the simplest way of representing them. We can look at some examples. Let's look at a carboxylic acid with one carbon atom. One carbon atom. We represent here the one carbon atom here. And so, that will be C. How many hydrogen atoms? If N is 1, there will be 2. And 2 oxygen atoms. Now, if we iterate the structure, the carbon atom is only one and it's the carboxyl group. This is the structure of the carboxyl group. And the two hydrogen, one of the hydrogen atoms is on the OH. And so the other hydrogen atom is here. So what does it mean? That this R that we represent in the simplest generalization of carboxylic acid is either an H or an alkyl group. But it can as well be an aryl group. This R here. So, if it's an alkyl group, then we would have example like 2 carbon atoms. 2 carbon atoms would be 2 carbon atoms would give us C2H. They are saying 2N. So this would be 4. And then this is O2. So 2 carbon atoms, we shall have CH3, COOH. In this case, the R is a methyl group. We could have other examples which have an aryl group. And this is benzoic acid. And this takes us to the nomenclature. The nomenclature of carboxylic acids. Now, just as we have seen in the previous functional groups or previous homologous series, most of these names come from the alkanes. So we are going to be this time replacing letter E of the corresponding name of an alkane with OIC, followed by the word acid. So we are going to say that they are named by replacing letter E of the alkane with letters OIC, followed by the word acid, to make what we call carboxylic acids. Let's name some and then appreciate the nomenclature. Let's begin with the simplest, with 1 carbon atom. The name of the alkane would be methane, because this is 1 carbon atom. But we are saying we are going to replace letter E with 3 letters, OIC. So the compound becomes methanoic. And we add the word acid, hence methanoic acid. If we go to 2, these are 2 carbon atoms. The corresponding name would be ethane. But we are removing letter E, substitute it with OIC to become ethanoic, and then follow the word acid, ethanoic acid. If it is coming from benzene, then this will be benzoic acid. That will be benzoic acid. Now, what if it has 2 carboxyl groups? For 2 carboxyl groups, the prefix di is put before letters OIC, and the position of the carboxyl group must be specified. For example, I may have a carboxylic acid with 2 carbon atoms, but each of them has a carboxyl functional group. And in that case, we would have HO, that's 1 carbon atom, that's another carbon atom. There are 2. So in this case, this is 2 carbon atoms. So we could name this one as Since it has 2, then it is ethane. If that's the alkane it comes from. So now, we are saying we are going to remove this letter E. This time, actually we should not even remove the letter E. We shall just now ethane locate the position 1, 2. On each of them, the first and second, there is a carboxyl group. So this is ethane 1, 2 dioic acid. Ethane 1, 2 dioic acid. This time, we don't replace the letter E, just fix in the position and dioic acid. Ethane 1, 2 dioic acid. What if they were 3? Oh, like that one. This one will be propane 1,3-dioic acid. We give 2 more. We give 2 more. These are 4. So this is butane 1,4-dioic acid. Then what if it was benzene? You have HO, then there is a benzene ring, and then like that. This one would be benzene. On the first carbon atom and the fourth, there is a carboxyl group. So 1,4-dioic acid. Benzene 1,4-dioic acid. So this is the nomenclature of carboxylic acids. Then briefly, let's share or let's look at isomerism in carboxylic acids. Isomerism in carboxylic acids. Now, if this is isomerism in carboxylic acids, then we are going to look, do they have structure isomerism? If they have structure isomerism, they have all the 3. They have the chain, position, and functional group isomerism. Yes, they have structure isomerism, but due to the structure of the carboxyl group, it is impossible for us to have the position. So the best we can talk about is functional group isomerism and structure isomerism. So we shall say that carboxylic acids mainly have functional group isomerism, and if not functional group isomerism, they can as well have chain isomerism. Functional group isomerism and chain isomerism. Now you realize that the first carboxylic acid, methanoic acid, may not have the functional group isomerism, may not have the chain isomerism, because it's just one carbon atom. However, for ethanoic acid, so we are going to say that methanoic acid has no isomers. But ethanoic acid has a functional group isomer. We can arrange this. This one has a functional group isomer. Functional group isomer. And in this case, we shall say that all, or we can say carboxylic acids, because now methanoic acid is not part, carboxylic acids are isomers. They are isomers to esters. They are isomers to compound called esters. And in this case, if you had ethanoic acid, then we must find a way of generating the structure of an isomer, of an ester here. An ester has the two oxygen atoms within the carbon chain. So if we wrote that, then we can have the CH3 there, such that we still have 4 hydrogen atoms, these 4, but this time the H is not on the oxygen. This time the H is on the carbon atom. And when we are naming this, we call this one, it is derived from ethanoic, this one is derived from methanoic acid. So we get methyl methanoate. Methyl methanoate. Now, next. If we go to 4 carbon atoms, C4H8 or 2. If we write the first structure, we would have CH3, CH2, CH2, COOH. Now, this compound has the ability to have both the chain isomer and the functional group isomer. Let's look at the functional group isomer first. And the functional group isomer is simply putting now the oxygen atoms within the carbon chain. If we wrote these 4 carbon atoms, instead of putting the OOH this side, we could design and put them in between here. And that would be an ester. And so the structure of the ester would be CH3C within the carbon chain. CH2, CH3. That's an ester. We can even put it on another carbon atom. If we put it on this one, it will be the same. We can put it maybe on the last. You can have CH3C or CH3CH2C. Now this one, we can decide to put this one here, or this one, an H, and that means this one should be CH2. This one is still an ester, and this ester is having the same number of carbon atoms like these other isomers. But we can have a chain isomer. Reduce on the number of carbon atoms in the continuous chain and create a branch like that one. This one is a branched isomer, and this one is 2-methyl propanoic acid. 2-methyl propanoic acid. These are esters, but this is a carboxylic acid, an isomer to this one. This is a straight chain isomer, this is a branched isomer. These ones are functional group isomers to those compounds, the esters. And here, in the esters, what is changing is the position of the ester group. These are position isomers of esters. So, the isomers present in carboxylic acids are either chain or functional group isomers. We either chain or functional group isomers, it is hard to have a position isomer and say carboxylic acid. That has been the introduction of carboxylic acid. In the next lesson, we shall look at the preparation of the carboxylic acid. Thank you. See you in the next lesson.